Hello and welcome to this Java tutorial. So when you start learning Java, you will definitely come across these three terms a lot, which are JVM, JRE and JDK. So in this video, we'll break down the differences between JVM, JRE and JDK in Java and explain their individual roles and show how they work together to run your Java applications. So, in order to understand these terms clearly, first thing you should know is what is bytecode in Java. If that is clear, then it will help you in understanding these terms better. So, we'll start with that. What is actually bytecode in Java? So, when you compile a Java program, it is not directly compiled into machine code. Instead, it is converted into an intermediate representation called bytecode. So let's try to understand this in detail. So first thing is, if you have any program, right? Nowadays we use high level languages, which means English like syntax, right? To write our code. But machine only understands machine level instructions, right? Kind of binary 1 0 1 1 0, something like that, right? So whatever you write in your code, that has to be compiled into machine level instructions that only system can execute. So that is the job of compiler. Then there is also an interpreter which does the same thing, convert your code into machine level instructions. How they differ is compiler take the whole file at once, everything in that, and converts it into a machine level instructions, whereas interpreter goes line by line. It will convert one line into machine level instruction, execute it, then another line, like that. And Java is both compiled and interpreted. It is both. You will use both in Java, compilation also and interpretation also. So there are languages which are only compiled, like C, C++, where you directly get machine level instruction after compiling a C program or C++ program. Then there are many scripting languages which are interpreted, like JavaScript or Perl, which do line by line. Then there is Java, which is both compiled and interpreted. So when you compile a Java file, let's take an example. Suppose I have a file named test.java. So when you compile it using Java C, what you get is a test.class file. So which contains the byte code for your Java file. Okay, so you can understand it like this. Suppose I have this test, right, dot Java. So I compile it using Java C. For that, Java gives you a tool called Java C, Java compiler. What you get is the file having the same name. So test.java, that means test.class. So extension of this will be .class. That will have the bytecode. So this is first step. Once you get this test.class file, this is then interpreted. So then line by line, this bytecode is interpreted, and that is done by JVM, and that will execute your program. So we'll see this code also. Let's try to do the same thing with the code and see, do we get a .class file and how do we get that. Okay, so let's try to understand this compilation process which produces bytecode. So suppose I have this program hello world.java in this location. Now if I compile it, for that I have to use Java C. If I go here, and just to show you the structure also, so this is the program, nothing much, it just displays this text. on the terminal. So if you don't understand this right now, for that we have another video, first Java program. You can watch that to understand how to write your program. Here we'll just understand how it produces bytecode. So coming back to our terminal, suppose I write here Java C and my program hello world.java. If there is no error, if I go back here, now if you see, it has created this dot class file also. So that contains the bytecode actually. You won't be able to understand much because it is kind of all special characters. Okay, now in order to run it, that's where JVM will help. And that is what you mean by two-step process. We have compiled, but what we got is a dot class, which is still not machine level instruction. Now, when we interpret it, for that we have to use this command. Then only it will be executed and we get the output. So that's what you mean by bytecode and two-step process in Java. Okay, now two things about bytecode are bytecode is platform independent. So if you have a dot class file that will run on any operating system, which means if you, let's say, develop a Java file, Java code in a Windows system and compile it, and you take that dot class file to a Linux system, there also it will run. So you may have heard that Java is platform independent. That is because of this bytecode. So you can take this dot class file after compiling your code in Windows machine, and that dot class file will run on Linux system, or vice versa. You can create in Linux file, compile a Linux system, compile it there, and take that dot class file to Windows system, it will run there. And JVM will interpret and execute this bytecode on the target platform. Okay, so I hope you are clear with some terms, what is compilation and interpretation. And Java uses both, so it has two-step process. It is both compiled and interpreted. And when you compile Java file, what you get is an intermediate kind of file, which is a dot class file that is interpreted by JVM. So with that knowledge, let's move to the JVM. So JVM is the heart of the Java ecosystem. So a lot of things are done by JVM, which is Java Virtual Machine. Because the name itself says virtual, though it's a machine, but it's a virtual. That means it's the software only, not some tangible hardware. So JVM, if you see, it loads your files, it verifies the bytecode, it runs that bytecode after interpreting, right? It also does memory management. So it does a lot of things actually. So first thing is it acts as an interpreter, which we have already seen. So JVM acts as a bridge between the Java programs and the underlying operating system. Actually, it does more than that. If you see, right? Suppose I have some Java code, right? Java code which I want to run. And this is our OS. So JVM sits in between and talks to the OS that, okay, I have to run this code, allocate some memory and CPU cycles so that I can run this code. That is also done by JVM. Then once that is done, it will start interpreting and executing it. It also verifies that bytecode actually. Whatever bytecode is produced after compilation of your Java program, JVM also verifies that bytecode to ensure that it is safe to execute. So JVM gets its classes through class loader. What happens is, suppose you have a big project, right? That will have a lot of classes within it. So all of these classes are not loaded at once, but those are loaded as and when needed. So JVM helps with that also. So suppose it is executing some code, then it sees, okay, it needs help of some other class. So at that time only, it will get that class. Actual loading is done by JRE, which is the another term, Java runtime environment, but to talk with JRE, that is done by JVM. Then, of course, it does the memory management also. So JVM has many runtime data areas. So it has many data areas which are divided into many parts. So first is heap memory. So all your objects which are created will go into this heap memory. Then there is stack memory. So that is the private memory for each thread. So method calls and local variables, all that goes into stack memory. Then in Java, if you keep creating objects, they also have to be cleaned. So that is also done automatically. You don't have to do it. So there is a process called garbage collection, which runs automatically. And that is also managed by JVM. So it looks for the objects which does not have any reference. And it will delete or clean those objects so that there is always memory for new objects. All that memory management is also done by JVM. So it has actually more data areas here, only few are listed. Now we come to one thing about JVM, which confuses beginners a lot actually. While Java itself is platform independent, JVM is platform dependent. And it is because of JVM, which is platform dependent, Java gets its platform independence. So let's try to understand this contradictory term. So we have already understood this thing, right? That JVA doesn't understand Java program as we write it. It only understands bytecode. And that dot class file you can take anywhere. So if it is compiled in Windows, you can take it to Linux system and it will run. Right? Dot class file, suppose created in Windows, you can run it in Linux. Why it will run is because you have a JVM which is specially written for Linux, which will interpret this dot class file as per Linux system. If you run it in JVM Windows, then there you have a JVM which is specifically written for Windows and convert this dot class file to machine level instructions which are for Windows. Same for Mac. So you see, right? JVM is different. And that is why you can run dot class file anywhere. So Java gets its platform independence because of this two-step process. From .java, you get dot class file, right? But you should have a JVM which is implemented for that particular platform. So JVM should be implemented for that particular platform and it should be installed for that platform. Then only your code will run on that particular platform. So if you have noticed, right, when you go to install JDK, you'll find different installations for Windows, Mac, or Linux. So I used to think if Java is platform independent, then why there are different installations for Windows, Mac, or Linux? There should be only one installation which should run anywhere. But then I realized it is because of JVM, which is different for each OS. So your Java installation for particular OS gives you the JVM for that particular OS. So if you install JDK for Windows, you'll get a JVM for Windows. If you install JDK for Linux, you'll get JVM for Linux. Okay, so I hope you are clear with what is bytecode, how JVM helps. So now we come to the second term, which is JRE, Java Runtime Environment. So JRE provides everything needed to run Java application. JVM itself, so JRE contains a JVM. Apart from that, it contains some libraries like java.lang, java.util, java.io and others, which gives you specific files for functionality like input output, so any file system, some utilities for core language itself. So it gives you a lot of files and some other files also. So what happens is when JVM starts interpreting, right? Java file compiled to dot class file interpreted by JVM, and it is interpreting some dot class file that may require some other functionality given by some other libraries. So these libraries, JVM will interact with JRE to load those classes, right? In JVM we saw, right, class loader. So this image shows that your Java file compiled to dot class file interpreted by JVM. While running, it may use some JRE libraries which are given by Java runtime environment. So that is the main job of JRE, to provide libraries and other files to the JVM while it is executing your code. So if you are only a end user, right? End user, which means just want to run Java programs, not develop them, then you just need JRE, means runtime, which can run the Java programs. But if you are a developer who need to develop and compile, then you need JDK, which is the third term, Java Development Kit. So JDK is a superset of the JRE, means it contains the JRE itself, and JRE in turn contains JVM. So JDK will have JRE plus JVM. Apart from that, it will have some development tools like Java C, which is your compiler, Java Doc for documentation, Java P, which is actually a disassembler. So using that, you can disassemble the dot class file to see the structure, and debugging tools also. Apart from that, it will have additional libraries for building, testing, and packaging Java application. If you want to create a jar file, that also you can do using tools given by JDK. If you want to see the thread dump, JStack utilities there, so many things are given by JDK. So if you are a developer who is developing and compiling Java file, you have to install the JDK. And end user, if you just want to run Java program, then you need JRE. So as a developer, you will need a JDK. So this is some explanation about these three terms. So I hope now you are aware about these three terms, JVM, JRE, and JDK. Thanks for watching the video. Please don't forget to like and subscribe.